All right, warriors, this is my first try at screencasting, and I'm hoping you're behaving for the sub today. For math today, we are going to be focusing on the following standard. You need to start 2-column notes. At the top, you're going to title it Area of Rectangles. You can see that right here, Area of Rectangles. It comes from lesson 2-1 in your math. And the standard that we are going to be working on is 6.ee. Yes, those are E's, not backwards 3's, Mariano. Dot two, no, I'm sorry. Erase that. On that. I'll get better at erasing. 6.ee.a dot 2.c. And what that is says the following. We're going to evaluate expressions at specific values of their variables. So you need to be writing this down in your notes. It's going to include expressions that arise from formulas used in real-world problems, and the end got cut off there. But what we're going to focus on is this part right here that says include expressions that arise from formulas used in real-world problems. And that's hard to circle. All right, we'll worry about the rest of it later, but this standard means that you have to know formulas. So the next 3 lessons that we're going to do from topic 12 are going to teach you formulas in area and perimeter. So in your notes, we're going to define area and perimeter. If I spoke too quickly for you to write down all of this standard, you can go ahead and pause the video at any time to catch up. All right, we're going to move on. And I'm looking at 12-1 and it's titled Area of Rectangles, the title of your notes. The question is, how can you measure the area of a rectangle? So first we have to know what area is. In your 2-column notes on the left-hand side, you are going to write the word area. And this should be reviewed from 5th grade, where you learned that area is the amount of surface a figure covers. It says it right here, but it is the figure. So we're going to look at a 2D figure, a flat figure, a flat shape, and we're going to talk about how much surface it covers. So one thing I want you to keep in mind, area is different than perimeter. If I tell you to go out and run a lap on the field, you are going to run the perimeter of the field, right around the grass, right? And that would be the perimeter. But if I ask you to go out and run the area, you would have to start here. Let me see if I can get another color. You would have to start here and run all the way up, all the way down. Ooh, it's hard to keep straight. All the way up, all the way down, all the way up, all the way back. You would have to run the entire inside of the field in order for you to run the area of the field. Because of this, when we talk about area, we are going to talk about units squared. because anytime we talk about what's inside the field or what's inside a shape, we talk about it in square units, and we'll get into that more later. Our problem today is Tessa is covering a bulletin board with fabric. So imagine putting our paper up on the board, but instead of paper, she's using fabric. The board is 4 feet high, so you can see that here. It's 4 feet high, and it's 5 feet long. How much fabric does she need? She doesn't need fabric to cover just the outside. She needs fabric to cover the entire inside of her bulletin board. So we need to figure out how much fabric she needs. One way to look at this problem is to use graph paper. If we used graph paper and we pretended that each of the little squares was a foot, we could draw her fabric 4 squares high, because that would be 4 feet high, by 5 squares long. That would be 5 feet long if each of these little squares was a foot. And then in order to find the area, we could just count all the little squares inside. So if we had a piece of fabric on the wall that was 4 feet high and 5 feet long, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 square feet of fabric that we would need. You see these are little squares because we actually need enough fabric to cover each of these little squares. So 20 square feet of fabric, and that's what it says over here. You can draw a picture and you can count the squares, pretending that each of those little squares are your units. In this case, feet would be our units. And so if we counted all of these squares, we would have 20. And then we write square feet as feet with a little exponent of 2. Because when your exponent is 2, it's actually squared. All right, and that's what we read here. Tessa needs 20 square feet of fabric. There's a formula that helps you solve this problem so you don't have to write out or draw out every single picture, because if we're dealing with big numbers, you would have very big pictures to draw. So if we look at where it says another way to do this would be to use the formula. In your notes, make sure on the left-hand side, you're going to write formula for finding the area of a rectangle. Put that on the left-hand side of your notes. Pause me if you need more time to write. On the right-hand side of your notes, the formula you're going to write is A equals L times E. That looks like it. I'm sorry, L times W. That looks like an E. It's not an E. It's a cursive L. They use a cursive L so it doesn't look like a 1. But what it actually stands for, and write this out in your notes the long way, area equals length It's hard to write with this tool. I need to practice. Times width. W-I-D-T-H. Please tell me, oops, I can't fit my H in there. Please tell me you were able to write that faster than me. So in this problem, When Tessa has a bulletin board she's trying to cover with fabric that's 4 feet high, we can go ahead and say that's either the length or the width, because when we're dealing with multiplication, remember, the associative property of multiplication says I can multiply these numbers in any order. So I can plug in 4 feet high as either the length or the width. In this case, they plugged it in as the width. You can see it here. They plugged in the 4. They substituted the 4 for the W. Okay, and then she needs 5 feet long. So they substituted the 5 for the L, and then they simply solved. So in this case, the area, and area is always represented by a capital A for the variable, equals 20 feet squared. And again, we have to square the feet or put that little exponent of a 2 because we're talking about all the area inside each of these little squares, these flat squares. Okay, so it's important to put in your notes that this formula right here means area equals length times width. Turn to a partner, use the sentence frame. The formula for area is area equals length times width, or A equals L times W. Now, turn to another partner and use that sentence frame again. You can even write that sentence frame in your notes. The formula for area is A equals L times W. You're going to use that formula for this entire lesson to work on problems that come next. If you look at the other example in your book, how can you measure the area of a rectangle? Sarah now is helping her father carpet a hallway. The hallway is a rectangle. All of the problems in today's lessons are going to be rectangles. It is 12 feet long and 3 feet wide. Notice this time they said that the 3 feet is talking about how wide it is, even though we're seeing it as how tall it is. How much carpet will they need? So we're going to do it the shortcut way. We know we could count each of these squares. 1, 2, 3, because we're talking about area. How many square feet is covered by 3 feet by 12 feet? Or we could use a shortcut. Our formula. The formula for area is A equals L times W. So in this case, A equals 12 feet long. We substitute the 12 for the L. 3 feet wide, or high. Substitute the 3 for the W. Multiply the 2 together, and we should know 12 times 3 is 36. We will get the wrong answer if you do not label it. The units in this case, we're using our feet, and we have to square it when we're talking about area. So we have 36 feet squared that they need of carpet to fill this space. If you would prefer to draw your pictures out as you work today, you need to ask the substitute for some grid paper. I know Mariah also has some available. Maybe she's willing to share. If you would prefer to use the formula, that's good, because the standard we're working on requires you to have the formula for area memorized. Make sure that's something you're working on this week so you can show me you've mastered this standard. Your job now is to complete the problems. On the next page, you're going to find the area for each figure, numbers 6 through 14 even. So your job is to complete numbers 6 through 14 even, and then find a partner and check your answers. If you have all the right answers, you can move on in the guru. If you and your partner have two separate answers, figure out why your answers are different and who can correct their answers. When you get to some of these problems, you'll notice that there are some fractions involved, and we have not gone over fractions yet. But we have gone over multiplication of decimals. And when you multiply your decimals, you do not need to line up the decimals. When you multiply fractions, that's going to be more difficult. So when you get to number 8, I want you to go ahead and change 15 and a half to the decimal 15.5. And then do your multiplication. When you get to number 10, 11 and 1/4 is going to be the decimal 11 and 25 hundredths. And I know some of you already know that, but it's the same as having 1/4 and change. So don't use this fraction, use this decimal. Don't use this fraction, it's actually the same decimal to do your multiplication. As I look around, the only other thing that might give you an issue is when you get to 12 and 14, it actually gives you the area and it gives you one side. You have to find the missing side. So in that case, substitute in the formula what you know. If you know the area, you know your formula is area equals length times width. Wish there was an easier way to write this. Then plug in what you know and use inverse operations to solve your equation. So the area here is 7 and 7/10 equals, and I can make this 3.5 the length or the width, so I'll plug it in for length. 3.5 times, well, I don't know the width. The width says y, so I'm going to write y. I'm going to figure out how I can get that y all by itself. In order to do that, I have to do the inverse operation of multiplication, which is division. So I divide this side by 3.5 to make 1, which means I don't have to write it. They cancel each other out. Whatever I do to this side, I have to do to this side. So I divide 7.7 by 3.5. And I know there are a group of you that are still working on division of decimals, so if you get stuck, stop, raise your hand, and ask the sub. You can also go back and replay my instruction right now. When you're finished with 6 through 14 even, move on to the next part of the guru and show me that you understand how to find the area of a rectangle.